Daniel. Today I'll be showing you how to make a simulation in Instance Fluent of a 2D wind tunnel simulation using air. Our wind tunnel is going to have 4 different parts: the settling chamber, contraction chamber, test section, and the diffuser. So since it's 2D, you first want to grab your project and just right click it, and you want to go to its properties, and then you want to make sure it's not showing up here. You want to make sure that you move it to 2D, so it's in 2D to begin with. Then after you do that, you're just gonna go to edit geometry. I like to use space claim, so I'm gonna use space claim instead of the design modeler, which is the older one, and discovery is the newer version of space claim. Let's let that load up. Okay, so now we're in space claim. You're gonna want to pick what you're gonna sketch and where you're gonna sketch it. So it's already in 2D for us, as you can see. Make sure I get this. Grab you a line, and then we can begin. So first you want to make sure that you're in inches, because the prompt is given to us in inches. Space claim option. Units, imperial, cool. Then I'm going to start with my line. So I'm going to make the section to the left of the axis, of the y-axis, the first 2 sections, and then the section to the right, the other 2 sections. So you're just gonna grab yourself a line, start at the axes. Now we're gonna go, so this is gonna be the second test section. The contraction chamber is gonna be 24 inches long. So make sure you get that. And then the first part, which is gonna be the settling chamber, is just gonna be a 15 inches long. Do that. Okay. Do the same thing to the other side. This part's gonna be the test section, and that's going to be 12 inches. And then the last part, the diffuser, is going to be 42 inches. So once we have that, we're going to get out of that. And then you want to select all of these. I want to make these let's see. Set as the mirror line, because we're going to make our wind tunnel. And so we'll begin with the settling chamber right here at the end. Its height is going to be 22 inches, so we're going to go 11 inches. Okay. Then we're going to go to the end of it, and we're going to our contraction chamber, which is going to be 24. And then the test section height is going to be 6 inches. So we'll just go to the test section, which is right here. So 3 inches right there. And then another 3 inches to the end. Actually, this one's going to look something like it's pretty convenient, this mirror feature. All right, this is our settling chamber, contraction chamber, test section. And then the back right here is going to go all the way to the end. But it's going to be a 3-degree half diffuser angle. So we're going to change it right here to 177. Should be enough. And then with that, we'll be able to our wind tunnel. And then we can just go to dimensions. straight line. You're gonna want to leave this center line. It's gonna, well, I guess we already have the center line because we did it on the axis itself. So we could just leave it in there. Just make sure we connect it. So we can delete that 42-inch one and just add. So we can get the little extra there. Make sure we get out of there. Want to delete these lines. It's actually, it'll let us. Okay. Okay. Now that we have our test section, we'll select it. I think since we did it on the axis, we actually don't need these. So you know what? Here's what we'll do. We'll make this a construction line just in case. We have our axis there, so we should be fine. So then you're gonna end sketching. As you can see, you're able to select the whole body, just exactly what you want. You're gonna go to fill and it should be a face fill. Oh, and before I forget, actually, we're gonna wanna, so, okay. So what's nice is that our edges are split, and we do want that. So we can later demonstrate our walls and our inlet and outlet. So I actually think right here we're good to go because it's already split. You just wanted to make sure it is. So once it is, we can minimize this, go to geometry. Should we update that? And we can go to mesh, edit our mesh. We'll go. Perfect. Came right in and the edges are split, which is nice. And then we'll just want to reset the layout, move this down just so everything can show up where it needs to be. We're going to right click on mesh, we're going to insert the method. We are going to do this geometry, apply. Then the method, we're going to want to use triangles. Once we have that, okay. And we're also going to want to insert the sizing to 0.01 or element size. And that should do. And then we're gonna. There you go. We're just gonna want to generate our mesh. See our mesh as well. Perfect. It looks quite nice to me. And then now that we can actually see our mesh, we also want to name our walls per se. So we're going to go here to the edge selector, control, and select our edges. So these are going to be our walls. Do that. We're going to press N. We're going to put walls. It's okay. Then this back edge is going to be our outlet. Outlet. And then this front edge is going to be our inlet. Nice. Once we do that, we are good to go. If everything looks okay. Yeah, everything looks fine. So then now we can just go here, just update. Make sure that's up here. Update the mesh from the virtual block and go to setup, edit. The student version gives you about 4 processors. We don't do double precision with that. As you can see, we finally loaded in. It did take a little while to load up, but now it works. So since we made our boundary conditions very clear and we defined them, our inlet is obviously right here, outlet is right here, wall is right here. First thing you want to do is go to models, open that, make sure energy equation is on. It's going to be the basis of all our calculations. The prompt tells us to use viscous laminar flow, so that's what we'll do. Right below it. Next, you're going to want to make your way down to materials, double check that the fluid is air, it is, and then boundary conditions. You always want to double check your boundary conditions, make sure the inlet is velocity inlet and the outlet is pressure outlet. Perfect. Walls are walls. Nice. You're going to want to make now your inlet, you're going to want to assign the velocity to it. And the way we find the velocity to the inlet is because it's just going to be rho 1 or rho A1 V1 at the inlet. And then what we're given is rho A2 V2. And so just by dividing over, you can find the velocity at the inlet, just the mass flow rate equation. And the velocity at the inlet is going to be 3.9715091. And this is all for the 60 hertz of frequency. This problem is going to be based on this velocity. Next, you're going to want to double check that your walls are indeed stationary. You don't want them to be moving because then that will affect the no-slip condition. They are stationary. Make sure you apply that. And then now we can actually go ahead and run this calculation. So when you run it, you want a high number of iterations, like 180 iterations, so you can get the most accurate data and then convergence of your values. So this looks about right. You're going to want to press calculate, yes, initialize. There we go. Quite quickly. And then we're going to want to begin with our results. Go to our graphics, contours, double click that. And then the first part of the prompt tells us to just get the contours for velocity and pressures. So we'll start with velocity on the wind tunnel. Here we'll select everything so you can see it. And then display. So our velocity, as you can see, starts at the slowest, and then it gets highest in the test section, and then it diffuses or slows down with the diffuser, because, you know, higher pressure, lower velocity, highest velocity, lowest pressure. You'll see that when I go to my pressure. Start with our static. There you go. So the highest static is when there's the lowest velocity, because our stagnation pressure must stay the same, and then it increases in the test section with the velocity. Or sorry, decreases in the test section because of the increase in velocity. Then you want to do dynamic. It's going to be the opposite of static. Lowest at the slowest velocity, highest at the highest velocity. Positive correlation with velocity. And then our total pressure is going to be here. Must be the same because total pressure doesn't change. Only static and dynamic that are inversely correlated will change. So it looks about right. Next, we're going to want to show our plots, more specifically our just plots along the center line of our wind tunnel. Now, we can get that center line by making a line right here, and that line is going to go from negative 1.18 to positive 1.18. And the way we got that is, if you remember when we first made our wind tunnel in the sketch, we made it right at the center of both axes of X and Y. So to the left we did half of the wind tunnel, and then to the right we did the other half. So that line is already made for us at the center of our sketch, which is right here. So we don't need to make a new line for that. We can just use the existing values from the x-axis, half to the left and half to the right. Then we're going to want to call that center line. And we're going to want to create that, and then that's where we're going to show all our plots from, the center of the test section, because we don't want to have any no slip or any viscous and shear. So yeah, you don't want really any boundary layer issues along the center. So when we go ahead and we run this, as you can see, the static pressure, it's going to just show up to be super high at the inlet because the dynamic property is the lowest, and then super low at the test section because dynamic is the highest at the highest velocity. Next, you're going to want to do the dynamic pressure. It's going to be the opposite of that. Inlet lowest, test section highest, diffuser, it's going to go down. It's going to decrease because pressure is going to increase. Velocity is going to decrease. And then lastly, you're going to want to do total pressure. And then your total pressure along the center is going to vary just a little bit, as you can see. But it didn't in the contours as you saw before. And that's all I got for today. Thank you for watching.